So it's about humanoid robotics, and humanoids is more than just AI, it's physical AI. And most of you probably get all those videos on your smartphone with the next fantastic thing a humanoid can do, and I'm very often asked by journalists and politics and so on, is it just a hype? Is it the next big thing? Will it be in my kitchen in 2 years? Will it take 40? And so on. And what maybe initiated the entire hype are quotations like this of Elon Musk, which goes back to 22, that basically they will sell more humanoid robots at Tesla than cars. And you hear quite often that humanoid robotics industry might become in 10, 15 years bigger than car industries, right? Or Jason Huang, who in Las Vegas this year said the ChatGPT moment of general robotics is just around the corner, right? We heard today about surprise for the larger society when foundation models came out, but they are living just in the digital data, in the internet, right? Now, if you want this AI to go out in the real world, of course, we have autonomous driving, but if you want to do things human can do, then you need even another leap step in robotics. And there are plenty of companies coming up, and of course, you might trust or not trust those studies, but there are crazy numbers around, right? Which make also investors and industry nervous, like saying, in like 2-3 years, we will have manufacturing, then business, then family, so everyone, instead of buying a second car, will buy a humanoid for at home. And then the numbers over here are tremendous. So these are thousands, right? So, no, 10,000 units, so huge numbers, right? And then also, after this start in US, also China responded with a huge program. They put, according to Süddeutsche Zeitung, about 140 billion into just humanoid robotics, with the consequence that you have more than 140 companies building humanoid robots with no application out there yet where they act in the factories. So the question is, what about us? How do we respond in Europe? What do we do about? And one place where we are discussing those things is a network of excellence in robotics, which I have the honor to coordinate, and where we have all the major research centers, or most of the major research centers in Europe, which are strong in robotics. And the question is, how can we respond with a good scientific excellence, maybe quite fragmented industrial landscape to this challenge? Right? And the main topic we wanted to focus on was transferability, because looking at my colleagues, for example, Tammy Masfur in Karlsruhe, or colleagues at TUM, right? We all have our humanoid robots on wheels, on legs, maybe other types of mobile robots, and we all focus on the same things: perception, human-robot interaction, motion planning, skillful motion, and so on, and repeat and reinvent the wheel again and again. So we said, what about if we can use the AI tools and the advancements in robotics such that, if our Justin lends a skill, for example, to unload your dishwasher, you can upload in the cloud, and in the cloud, and the next day another robot can do the same thing, even though it has a different morphology, not even humanoid, but maybe on a Segway, or just having one arm. So this is what we are looking at. Somebody talked about hackathons just before lunch. This is what we are doing. At least once a year, we get together with 200 people, put 30 robots together, and try to solve things in competitions, but what we call cooperative competitions. So you earn points if you solve a task. You earn 10 times as many points if you solve a task using software modules from somebody else, to just foster standardization, integration, and so on. And here are some images from the co-petition we had in Nancy after the Humanoids conference. And this was our Justin robot. This is KAT from Karlsruhe. We had one league for home robotics, so unloading the dishwasher, going and bringing things to the fridge, interacting with humans. Then we had the industrial part with a task board coordinated by our colleagues at TUM, where you have a standardized benchmark with Internet of Things devices. These are the colleagues from ETH Zurich. They have a quadruped with wheels, so it doesn't need to be humanoid, right? Here you have a drone which has arms, and they had a scenario of last mile delivery. So, and here you have a centaur, legs and wheels and 2 arms, right? And they are bringing the parcel to your home. So these were the 3 tasks: home environment, this is INRIA from France, home environment, industrial, and last mile delivery. This is a group from Italy, which had a telemanipulated robot. So it was big fun, and we also saw the chances, but also limitations of robotics. Now, I will try to go through some aspects, right, to say what are the challenges and where are we, right? And building humanoid robots, Japanese were among the first. This Ashimo in 2000 was the first to be, recognized by public. There were developments in the 90s as well. Now we have plenty of them. And of course, there's the question, what kind of actuators? How can you do it more efficient, faster? There's big development also in actuation, in power electronics, also with electric motors for electric cars, for wind turbines, for so many new applications. So there's a shift in power density of actuation. Building such systems, there's still a competition. How does the ideal humanoid look like? Just to answer your question, no, you don't need wheels all the time. If your factory is flat, you don't need legs, right? You can use wheels. But the point is, if a newspaper wants to speak about AI, they would put such a robot on their cover because everyone is then sure, oh, this robot is intelligent, just because it looks like a human, right? While if you put a centaur, you don't know exactly, right, how smart is a centaur. So something has also to do with communication and with the fact that it's easier to get investment for a humanoid than for a robot with 8 legs and 7 arms, for example, right? But it's also related to the fact that our homes are all designed for us, so for our hands, for our bodies. So if you have robots to do whatever you do at home, probably it needs to look a little bit similar, to climb your stairs, to grasp all the objects which you have in your home. So it's not the ideal solution, but it's something which, it's good in human environments. And interpretability is another aspect, right? If you watch a humanoid, you moving in a human kind, you kind of have an expectation and a prediction what it could do. Okay, I mean, the technology has been around for a long time, right? And when people talk about in 2-3 years we will have them in the homes, I'm a bit skeptical about that, right? Just because we started, I did my whole career develop cobots. And we had a first prototype after about 8 years in 2003, and then we licensed it to KUKA, then Franka, Emika, Agile Robot. A lot of companies bring those robots to the market. But from the start of the development, from the first working prototype, 2003, it was like 8 to 9 years until the first companies had the products, right? We licensed this to Medtronic, to surgical robotics. We heard about that. So a big industry emerging, but it's deep tech, and it takes 10, 15 years at least, right? So, and now we are doing it also for space. Space is even slower. But then you can use the actuators and then build humanoids like Toro, Justin. And of course, now things change, right? We never had that amount of investment, of talent in robotics, right? Companies had maybe a few thousand employees. Now the big tech companies go into the game. So maybe, this will also accelerate entire development. Now, when you see those videos, you see, walking, balancing, doing some acrobatics. This is still, I think, to a large extent solved. So, robots can react in a pretty human-like kind, either by machine learning or by other model-based controllers. We have also robots which can interact with humans, which are safe for interacting with humans, although they have pretty high power density. So I think these things are well solved, and the big game changer in the last years came from ETH Zurich, NVIDIA, where you train massively in simulation with GPUs parallel. Because the point is, in contrast to speech translation, to language recognition, we don't have the physical data in the internet, right? You have a lot of labeled text in the internet to train your large language models. But how to get the physical motions, the connection between the camera input and the motion of the robot? You don't have those data on the internet. So you could do simulation like this, but there's still what is called sim-to-real gap, which is still not completely solved challenge, right? So does your simulation match well enough the reality? It works sometimes not so well, right? But this is where we are, and most of the fancy videos you see also from Japanese or Chinese robots are used with this kind of reinforcement learning tools from NVIDIA. But then what came additionally to hardware and control are the entire developments of AI in its different kinds, right? And when people talk about humanoids, many focus on the legs, but many forget that hands are even more important. So this homunculus is just an illustration of the proportion of the brain which is used for different body parts, right? So it's scaled up if your brain, a big part of your brain is addressing those parts. And this is for sensors and actuation. And what you see is that most of your brain deals with the hands, right? Both for perception and action, then with the lips, with speech and so on. Sight and legs are not even that great, which shows that indeed manipulation, handling all those objects is still a largely unsolved task in robotics, and we are just, getting better and better on that aspect. And again, here you can use this reinforcement learning, sim to real, right? Even manipulating a cube or grasping different objects needs millions of training cycles in simulation. And then you can manipulate certain objects. So there's continuous progress. When are we there that you can manipulate all your objects in your home? I don't know yet, right? The other aspect, some example we have in our case of the challenges we have and where you use AI, right? You have a camera. You recognize, of course, only the front of the object. As a human, you know how the object most likely looks behind. So you have an AI part which does the shape completion and then generates the grasp, so tells you where to put each finger, how to bend each joint, such that you grasp the object. And then you can put arbitrary objects on the table, and within 1 second, this AI pipeline generates a grasp such that you can pick objects, right? How to train vision. Meanwhile, we have simulation tools where you can generate synthetic visual data to train your vision algorithms, right? And so data generation is one of the big challenges. This is an example of a company from California coming out from Stanford, and they are folding laundry. It's an impressive demonstration. Mainly, they do teleoperations, so they have lots of people. Also, many other companies figure they use hundreds of people to teleoperate robots, and they record those data, and then they use those data for training. So data are still very, very expensive. And I think solving that, so there are still unsolved methodical issues in order to scale really at large. Some are very optimistic and say in 2 years it will be solved. Some say it will take longer. And now we have foundation models which help in explainability, in planning, in several aspects. I won't go in details, but there's a big discussion going around about, will you have one big foundation model where you put the camera of your robot, the input data of the camera, and the foundation model will give you motions for each of the 40 joints? Or is it rather like in your brain that you have a cognitive architecture for perception, for planning, for cognition, and so on? So again, research going on, right? So humans, it's in our brain, it's not an amorphic structure, but we know where perception is, where world model is, where planning is, where reasoning is, and so on. Okay, now some applications. I'm from the German Aerospace Center, so we are developing robots to go to foreign planets and have done experiments with astronauts over several years to train them and to learn how they would operate robots on a planet. So imagine this is Alexander Gerst, this is the other one is a NASA astronaut, and they are operating several robots in our institute. They look through the eyes of the robot, can also go and operate them as avatars and feel the forces when they interact with the environment, but they also can use AI skills and just tell the robot, go and pick, I don't know, this electronic box. And they face challenges like, smoke comes out and they need to replace something from the electronic cabinet and so on. The goal is at the end to have a humanoid on Moon and on Mars. We know Elon Musk wants to have one. We still hope in Europe to maybe bring the first humanoid or legged robot to Moon. There's a big discussion going on. The decision will be made in November by European Space Agency. This is our robot demonstrating that something like this is feasible. This is an AI video generated by ESA. 1 week later, we did this video showing that it's feasible to walk on sand and terrain like on Moon. And then the topic which makes also the connection to the next talk is humanoids in everyday life, having addressing the challenge of demographic change, both in hospitals, in homes, in public spaces, and so on. I mean, this kind of flaws probably all of you know. Those people will retire in the next 15 years. Those people will come into as workforces. In Germany, it's a delta of 4 to 5 million. In Europe, it's 20 million in 10 years. We will lose from the working market. So having robots to help people stay longer at home, not needing care, but being independent, either as humanoids, or actually they don't need to be always humanoids. And of course, humanoids you can operate. AI is not good enough yet that they would do the job independently. But what we do is we have a call center with somebody which can log in as a teleoperator, and if some problems occur, they can teleoperate the robot. Then you can record those data, and based on those data, you can improve the skills of the robot. I mean, that's how the market will scale and grow, right? But it's not just the humanoid helping, but, and this is Annette Hagenruber and Jörn Vogel who will present our robot. You have also things like a robot on a wheelchair helping locked-in patients like Stephen Hawking, for example, with AI skills. This is our team participating to a competition at the ETH Zurich. It's a kind of Olympic Games for people with disabilities. We got the first prize there, and this motivated our team to start up a company based on that. And this is only possible. People are in full in the driving seat, they decide what the robot should do, but AI helps them accomplishing the tasks. And this can be in home, in hospitals, and so on, with a call center. And this is my last slide. So the big question is, I know very well how to, what's the market for 100 million robots, but how do you sell your first 1,000 robots, right? It's difficult because, to enter this exponential curve and scaling. And that's why we think maybe not the perfect humanoid, which is maybe 10, 15 years away, but some more simple and easier to achieve goals can be the solution, where you start more with teleoperation, start generating data, and based on those data, you improve your quality of the AI and improve your services up to the point that you can provide services to the entire community. And this is actually the direct transfer to Annette, who will take over and will present you the wheelchair. And from my side, thank you for your attention.
So thanks to Aline, we could already see some research that we are doing in German Aerospace Center on assistive robotics. And we're very proud that today we can present you our new prototype for our planned spin-off Enabling Robotics, where we want to empower people for more independent living. But before we go in details, let's take a step back and think of essential tasks that we just all do every day: drinking a glass of water or eating. And we all do that automatically, we even don't think about it. But think about that people having an accident or an injury that need help to do so. They need sometimes 24 hours assistance to do all tasks of daily living. And now imagine further, there is no one that can help them doing these tasks. And it's not a secret that we are running in a care crisis. In 2049, it's expected that we are missing up to 690,000 caregivers alone in Germany. And technologies like robotics can contribute to solving that problems. But what we all wish for is, when there is this point, that there is this robot that can do everything for us, helping us, supporting us with all tasks, while being very safe, robust, and reliable, which is necessary in an unstructured and dynamic environment. But right now, such a robot is not existing yet. And that's why we, addressing a group of people where I address robotics, can already nowadays create real value. And these are people with motor impairments. So these people are very often fully engaged in life and want to be active. And with the help of their wheelchair, they are mobile. But they're still not independent. As soon as they come to a door or an elevator, they cannot press the button or handle the door. And this is where our system comes in. Our solution, an AI-driven manipulator for empowering independent living. And here I want to switch over to my colleague Jörn Vogel, who will show and present our system in detail.
So welcome from my side, and I'm very happy anyone hear me? Yeah. Very happy to present you our robotic system, Maya. You can see that we built a robot arm specifically designed to this application. So it is safe to interact with. It can be controlled with the user interface of the wheelchair. And if you want to drive the wheelchair, you can stow it away so that it doesn't obstruct you while driving. We also have a camera on board that detects the scene in front of the robot to help with interaction with objects. And we have a tablet here which gives information to the user to know what the robot can support with. And I will quickly demonstrate this now. So as said, I can I can now decide whether I want to drive the wheelchair or operate the arm, and can use the same input device to do this operation. And then basically all I have to do is to approach the environment or the objects I want to interact with, unfold the arm from the parking position, and from here on I can use again the same interface that I used for the wheelchair to operate the arm and move it in space. And the camera now sees the objects in front of me, detects them, and allows me to interact with them. An interaction I can start by simply approaching the object with the arm. So I move towards this bottle. Now, it's similar to a lane-keeping assistant in the car, where I get guided to get the bottle between the fingers, but I can still give some or have some control on how the task shall be performed. So you can see how the gripper is always pointing towards the bottle, because I can decide from where I want to actually pick it and just move closer into the bottle to finally execute the grasp. And now the robot knows that it has a bottle in its hand and can give further support with that. So if I move close to a cup, then the logical consequence of or combination of a bottle and a cup is that I probably want to pour. So again, the robot assists with the task execution. It does all these rotations, orientations, while I basically just proceed along the task or can move out of the task. And when I don't give any inputs, also nothing moves. So it's really important that the people can stay in control. And this way, I can basically pour a cup of water here to drink from it. And then I can move out again. I can decide how much liquid I want to pour. And in this way, I can interact easily with the environment using the same input device that I also am used to from controlling the wheelchair. And speaking of the wheelchair, there's one more feature I want to show you, because we can also combine the abilities or the movement capabilities of the wheelchair with that of the arm, for instance, when you want to do a task like opening a drawer or opening a door and passing through. And as we also saw in Aline's talk, and Annette also mentioned it, we also have these different levels of autonomy where we want to proceed towards service robotics. So what I can do with our system is I, again, approach the object I want to interact with, and now I can tell the robot, please autocomplete this task for me. And at this point, we basically have sort of a service robot inside the environment. And if things fail, I am still in control to correct for the task and can still proceed and interact with the system to compensate for this.
Okay.
And with this, I want to give back to Annette.
Can we get the slides back? Thank you. So our goal is really that we're having an easy robot control and make it possible also for people with strong motor impairments to really to make it possible also for these people to interact with their environment and empower them. So what are the benefits? So for the user, it's somehow quite clear. They can have more independence in their life. And what is very special, they can be by themselves again. So people can close the door and be really alone. This is something sometimes very special for these people. But we're also in contact with different partners from the health insurances and from the health system market to also bring a benefit to both sides, a win-win situation, for example, to how to bring such technologies in the market and, for example, create new care models which are not possible without these technologies. And at the end, there is a benefit for all of us, having people that we can better include in social life and that can stay longer and work. So on the one side, with our solution, we can empower people with motor impairments to physically interact again with their environment. And on the other side, we have the possibility to bring autonomous robots in households and gathering real-world data that no one else had. Exactly what Aline said before, really seeing that gap, how to gather this data. And this data, together with our human-in-the-loop approach, we can boost the robot capabilities and increasing autonomy capabilities continuously. So it's a win-win situation for the user and the robot. As we saw directly, so if there is something not really working, you don't need 100% reliability. The human can help the robot, and the robot supports the human. So by increasing the capabilities, also the user getting a better system, more autonomy gets in. And at the end, this unlocks new market. With the increasing autonomy, new applications are possible, and with this we can go on new markets for autonomous service robots for clinic, care, and even beyond. And this brings us back also to the care crisis, where we directly can address this with this system. In our founding team, we have a lot of knowledge over the years in assistive robotics, healthcare, and AI. And together we want to found Enabling Robotics, and we are happy if you get in contact with us, we are also later downstairs in the networking area, and I think later also some questions.
Hello. So today, construction is one of the most manual and inefficient industries in the world, while in other sectors, for example in factory halls, productivity increased by over 800% over the last couple of years. In construction, productivity actually declined because it still heavily relies on manual and physical labor. Now imagine a future of construction where no human worker needs to bend over these manual tools anymore, but instead intelligent machines are performing the heavy lifting on construction sites, and the humans just stand beside and oversee the quality of their work. This is not science fiction, it is what we build with Zeitgeist Robotics right now. Now, let me tell you, it's not that easy to automate construction. Construction sites are dirty and they are very chaotic. They are changing every day, and no construction site is like the other. So you cannot simply drop normal machines onto these construction sites. Instead, we need a new kind of robotic system, and we are building the first of its kind. We are building a modular and intelligent construction robot. Intelligent in that it can understand and observe its environment and safely work beside human construction workers. And modular in that it can easily be reconfigured to the specifics of each construction site. Our construction robot can perform multiple construction tasks simply by switching the tool the robot holds in his hand as a human construction worker. And we are starting with one of the toughest jobs on construction sites that you can imagine, and this is concrete removal. So when construction workers are removing concrete, they spray with high pressure water against the concrete wall to remove the concrete. And it's such a physically draining work. 30 kilograms are pushing against your shoulders while performing this task. So the construction workers need to switch every 30 minutes. And although 2 construction workers are performing the tasks, humans can only remove 1 cubic meter per day. Our construction robot can remove 3 cubic meters per day. It does not need any breaks and just one human construction worker supervising its work. So it's really a massive productivity gain for our customers and real cost savings here. Concrete removal is just the first task that we are automating. We are already implementing other tasks like drilling and plastering. So while over time we increase the tool or the construction task portfolio, having our robots on site, we also collect very valuable data, which allow us not only to increase the level of autonomy of our robots on construction sites, but also offer new digital services like automated invoicing on construction sites. Ultimately, the ecosystem that we build will set and define the new zeitgeist on construction sites. We are supported in this big vision by a governmental fund of 1.2 million from the Federal Ministry of Economics and by various initiatives from the Munich ecosystem. And we are also mentored by experienced founders from the Munich ecosystem, for example, the founders of Konux and RockPro, but also on an international level, for example, Michael Baum from the US, the founder of Splunk. We are a co-founder team of 4 co-founders, Julian, Klaus, Lena, and I, and we bring in deep expertise in computer science, robotics, engineering, and business. So I believe we need to rethink how we build, and with Zeitgeist, it's not only about building robots. We are building a future where no human construction worker is worn out anymore, but instead they are supported, and where construction companies are not bottlenecked by labor shortage, but instead they are getting more productive, and where we as a society can finally tackle the massive renovation backlog that we are facing. So that's the future I believe in, and we would love to build it with your support. Thank you.